Your blood is about to boil, not a metaphor, not a figure of speech. Actually, physically boil, right inside your living body, without a spacesuit space, would kill you in the most horrifying way imaginable. And the truly terrifying part, it would all happen in roughly 15 seconds. That is what happens to your body in space. And most people have absolutely no idea just how brutal the physics of the universe become when they get to work on human flesh. But here is the part that kept me up at night researching this video. NASA hid something, a discovery about what long-term space exposure does to the human body that was not included in their initial public announcements. Something so alarming that researchers were not sure how to talk about it. I will reveal exactly what that finding was toward the end of this video. And I promise you, it is not what you are expecting. In the next 10 minutes, we are going to walk through every single system in your body. Your blood, your lungs, your bones, your muscles, your brain, and yes, even your DNA, and show you precisely what the vacuum of space does to each one. Buckle up, because this gets dark very fast. Picture this. You are floating in low Earth orbit. Your spacecraft has just suffered a catastrophic hull breach. Your spacesuit has failed. You have exactly 15 seconds of useful consciousness before everything goes wrong. This is not science fiction. NASA has modeled this scenario in excruciating detail because something close to it has actually happened. In 1966, a technician named Jim LeBlanc was testing a pressurized spacesuit at the Manned Spacecraft Center in Houston when the pressurization hose accidentally disconnected. He was exposed to near-vacuum conditions inside the test chamber. His last conscious memory before passing out was feeling the saliva on his tongue begin to bubble. He woke up fine. Barely, and only because the chamber was repressurized almost immediately. That is the entire margin that separates survival from catastrophe. 1, 2 seconds. All air evacuates your lungs. 2, 5 to 10 seconds. Blood pressure crashes and consciousness fails. 3, 15 seconds. Complete unconsciousness. 4, 90 seconds. Irreversible biological damage begins. 90 seconds. That is the full window between life and a death no textbook ever fully describes. 90 seconds total, but the individual processes happening inside your body during those first 15 seconds are each horrifying in their own right. And the first one involves something that is supposed to stay inside your veins. But in a vacuum, it decides to do something else entirely. Something that sounds medically impossible until you understand the physics behind it. Stop and think about this for a second. Your blood is liquid right now because of pressure. The atmospheric pressure pushing against your body at roughly 14.7 pounds per square inch at sea level keeps dissolved gases in your bloodstream from forming bubbles. Remove that pressure completely and instantly, and everything changes. This condition has a name. It is called ebulism, and it is one of the most nightmarish things physics can do to a living body. The dissolved nitrogen in your blood immediately begins to nucleate into bubbles, not just in your veins, in your joints, your organs, your skin tissue. Your entire vascular system starts to foam like a shaken can of carbonated water that has just been violently opened. Your blood, literally, begins to bubble inside your living veins. The medical community knows a mild version of this as decompression sickness. The bends. Divers who ascend too quickly can develop this condition over hours. In space without a suit, it happens in seconds. And simultaneously, the water in your body, which makes up roughly 60% of you, begins to vaporize at body temperature because water boils at dramatically lower temperatures when there is no ambient pressure to suppress it. Your tissues start expanding from the inside out, instantly. If that just disturbed you as much as it should, wait until you hear what is happening to your lungs at this exact same moment. Because what they do in a vacuum is even harder to process without flinching. Your lungs operate on a beautifully simple principle. They expand to pull air in and contract to push air out. That mechanism has kept you alive every moment of your existence without you thinking about it once. In space, without a suit, that same mechanism becomes your worst enemy. The moment you are exposed to vacuum, the pressure difference between the air trapped inside your lungs and the absolute nothingness outside creates a violent explosive force. If you make the mistake of holding your breath, which every survival instinct in your body will be screaming at you to do. Your lungs will rupture. The alveoli, those tiny air sacs responsible for transferring oxygen into your bloodstream, will literally shred apart like wet tissue paper under a pressure washer. But even if you exhale immediately, even if you do everything exactly right, your lungs still collapse. Without atmospheric pressure maintaining inflation, they fold in on themselves like deflated balloons with nothing to support their walls. The correct response is to exhale immediately, which is almost impossible to force yourself to do. You would remain conscious for perhaps 5 to 10 more seconds, enough time to feel every moment of the collapse. And with your lungs gone, your heart keeps pumping. For a few more agonizing beats, it circulates blood toward organs that can no longer do anything with it. The cascade failure has begun. If the science of what space does to us disturbs you as deeply as it should, hit like and subscribe, because we are just getting started. Because next, your body itself starts changing shape in ways that should be physically impossible. Now forget everything you think you understand about what a human body looks like, because this next part sounds like it belongs in a horror film, not a physics lecture. Without the constant pressure of our atmosphere pushing against your body from every direction simultaneously, the water and gases trapped in your tissues have absolutely nothing to contain them. They expand, dramatically, unstoppably. You would swell to twice your size. We are talking about your body visually doubling in volume. Your face would become completely unrecognizable. Your limbs would balloon outward against your skin. The soft tissue beneath every surface would push outward with nowhere to escape. This was actually documented in early space program animal experiments during the Cold War. Animals exposed to near-vacuum conditions in controlled Soviet-era tests swelled to grotesque proportions, their forms barely recognizable as the animals that had entered the chamber. Here is the detail that most people never hear. You would not explode. Your skin is remarkably tough and tensile. It would contain the expansion. But the internal pressure this creates on your organs, your blood vessels, and especially your eyes is catastrophic in a different, perhaps more disturbing way. The pressure on your eyes alone would push them partially from their sockets. And here is where the story enters an entirely different dimension. Everything we have covered so far happens in the first 15 seconds. What space does to a living human body over days, weeks, and months, that is a completely different category of horror. And the first long-term weapon space deploys targets something your body spent your entire life building, one mineral deposit at a time. Now let us say you survived. You have a functional spacesuit, a working spacecraft, and you are safely in orbit. You have beaten the vacuum, but space has other weapons, and this one is completely, terrifyingly invisible. Earth's magnetic field and thick atmosphere form a massive layered shield, deflecting and absorbing the vast majority of solar radiation and high-energy cosmic rays that stream through the universe at nearly the speed of light. The moment you cross beyond that shield, you step into a particle storm that has never once stopped. Astronaut Scott Kelly, who spent a full year aboard the International Space Station, absorbed a radiation dose equivalent to roughly 10 chest X-rays every single day. And the ISS still receives partial protection from Earth's magnetic field. Go to the moon, and those numbers multiply. Go to Mars on a 3-year round trip, and they become a mission-defining medical crisis. The radiation environment of deep space is not something we can fully protect against with current technology. It represents a fundamental constraint on human exploration beyond low Earth orbit. The truly terrifying element is what these particles actually do. They do not hit your skin and stop. They pass straight through suit material, through spacecraft walls, through your body. And when a high-energy cosmic ray threads through your DNA, it snaps the molecular bonds like dry twigs. Invisible, deadly, unstoppable. Elevated cancer risk, cataracts, a compromised immune system. But the damage goes far deeper than that, and the next system space dismantles. It is something you will never fully recover once it is gone. Here is something nobody ever pauses to consider. Every single day you spend on Earth, gravity is silently attacking your bones, and your bones are quietly, relentlessly fighting back. That constant battle. Gravity pulling down, bones resisting. is precisely what signals your body to keep rebuilding, keep fortifying, keep depositing calcium and minerals into your skeletal structure. Remove that battle completely, and your skeleton receives a signal it was never designed to receive. Stop building. Start dissolving. Astronauts lose approximately 1.5% of their bone density for every single month spent in space. Let that truly sink in. Women with diagnosed osteoporosis, considered medically high risk for life-altering fractures, lose roughly 1 to 2% of bone density per year. Astronauts lose that same amount in 30 days. An astronaut returning from a 6-month ISS mission can have the skeletal profile of someone decades older than their actual biological age. But it is not just the rate that alarms researchers. It is precisely where the bone loss concentrates. The weight-bearing bones suffer most severely. The hips, the femurs, the lumbar spine. Precisely the structures you need in order to walk without fracturing, stand without collapsing, survive a simple stumble. NASA astronauts perform 2 full hours of vigorous resistance exercise every single day aboard the ISS just to slow this process. Not stop it, slow it. Some changes to bone microstructure after long-duration spaceflight may be permanent and never fully reversible. The internal scaffolding does not rebuild quite the same way once it is lost. But bones, at least, are structural. What space does to the living tissue surrounding and moving those bones, that devastation is no less relentless. Here is what nobody tells you about losing muscle in space. You do not lose it because you are being lazy or sedentary. You lose it because your body is ruthlessly, brilliantly efficient. And in zero gravity, maintaining large muscle mass is an expensive biological investment it has absolutely no reason to keep making. On Earth, your muscles are working constantly. Even sitting completely still in a chair right now, your postural muscles are continuously firing just to hold you upright against gravity. In weightlessness, that entire category of constant background work disappears overnight. Your body eliminates the expense. Within just a few days of weightlessness, muscle protein synthesis drops sharply. Your body begins cannibalizing muscle tissue for fuel and amino acids. The leg muscles, the ones used least in microgravity, can atrophy by up to 20% in only 2 weeks. But here is the detail that makes this acutely alarming. The same process that dismantles your skeletal muscle also targets a very specific muscle you cannot afford to lose, your heart. With no gravity to fight, your heart does not need to work as hard to circulate blood around the body. So it quietly, methodically becomes smaller and weaker, restructuring itself for a world without weight. Astronaut Jerry Leininger, who spent 132 days aboard the Mir space station, described his return to Earth as feeling like he had suddenly aged 40 years overnight. After 5 months in space, returning to gravity felt like being born again. Except that every system in my body was screaming at the sudden insult of it. And yet even this is not the most disturbing thing space does to you. Because what I am about to reveal reaches all the way down to the core instructions written inside every single cell in your body. Now here is where it gets truly disturbing. Scientists have only recently begun to understand what extended spaceflight does to the human brain, and the results have quietly alarmed neuroscientists and space medicine researchers in equal measure. In 2019, researchers published a landmark study in the New England Journal of Medicine, analyzing detailed MRI brain scans from astronauts taken before launch, immediately after landing, and at follow-up intervals stretching years later. What they documented was both remarkable and deeply unsettling. The brain physically shifts upward inside the skull during spaceflight and does not fully return to its original position. Without gravity consistently pulling cerebrospinal fluid downward, that fluid redistributes throughout the skull. The brain itself floats higher inside the cranium, making contact with regions of the skull it was never anatomically designed to touch. Over months, this creates a condition called intracranial hypertension, dangerous fluid pressure that presses steadily against the optic nerves at the rear of each eye. Brain floating, pressing, shifting. The result is staggering. Roughly 40% of astronauts completing long-duration missions return to Earth with permanently degraded vision. Some describe it as looking perpetually through a window that was never quite cleaned. a slight but persistent blurriness that stubbornly refuses to fully resolve months or even years after landing. The brain adapts, yes, but adaptation and preservation are emphatically not the same thing. The question haunting space medicine researchers right now is brutally simple. How much neurological adaptation can a human brain undergo before that adaptation becomes permanent, irreversible structural damage? But what comes next makes all of this look almost minor by comparison. Because space does not just rearrange your brain, it rewrites something far more fundamental than structure. If you thought that was disturbing, you are genuinely not ready for this. In 2015, NASA sent astronaut Scott Kelly to the International Space Station for a full year-long mission. His identical twin brother, former astronaut Mark Kelly, stayed on Earth as the control subject. They were genetically identical. Same DNA sequence, same biological baseline, same history written in every cell. When Scott returned in March 2016, NASA launched the most comprehensive biological study ever conducted on a single human being, comparing every measurable marker between the two brothers across years of rigorous follow-up testing. What they found shook the research community to its core. Changed. A full 7% of Scott Kelly's gene expression had been permanently altered by spaceflight. 7% of his genes were still showing abnormal expression patterns 2 full years after his return to Earth. 7% might sound modest. In biological terms, it is staggering. And these were not just the anticipated changes to immune function or metabolic response. His telomeres, the protective caps at the ends of his chromosomes that govern cellular aging, behaved in a pattern nobody predicted. In space, they actually lengthened. When he landed, they rapidly and dramatically shortened again. His chromosomes aged the equivalent of months within the span of days. Space rewrites your DNA, cognitive function genes, immune architecture, DNA repair pathways, all showing persistent changes years after landing. Scott Kelly returned from space as a measurably, permanently different human being than the one who had launched. Which fact from this video changed how you think about space exploration? Comment, volunteer if you would still go, or never if this convinced you otherwise. I genuinely want to know. I promised you at the beginning of this video that I would reveal something NASA discovered. A finding so alarming, it was quietly absent from their initial public announcements about the Scott Kelly mission. This is it. When NASA researchers reviewed the twin study data and confirmed that 7% of Scott's gene expression had permanently changed, their immediate internal response was not scientific curiosity. It was a mission safety crisis. Because if 1 year in low Earth orbit on the relatively well-shielded International Space Station can permanently alter human genetics, what does a 3-year round trip to Mars do? What does a generation-long deep space voyage actually cost the people who make it? That is the question that now haunts every serious discussion about sending humans beyond the moon. The human body was never designed for space, and space does not care. Every astronaut who leaves Earth's protective magnetic field is making a trade most people never fully comprehend. Their bone architecture, their muscle mass, their cardiovascular efficiency, their visual acuity, their neurological structure, their very genetic expression. All of it permanently and measurably changed in exchange for the extraordinary privilege of floating among the stars. We are fragile enough to be destroyed by a vacuum, but bold enough to walk in it anyway. And here is what I find most extraordinary about all of this. The astronauts who know every single one of these facts, who have felt this in their own bodies, who carry the evidence written in their changed genes, they line up to go back every single time. As Carl Sagan once beautifully wrote, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." Maybe space changes us so profoundly because at some deep level, we are returning to where we came from. Fragile, bold, unstoppable. If you made it this far, prove it. Comment star stuff below. You are part of a rare group who actually wants to understand the terrifying, beautiful truth about the universe and what it costs to reach for it. That is exactly who this channel exists for. We started with a single terrifying fact. Without a spacesuit, your blood would boil, your lungs would collapse, and your body would swell to twice its size in roughly 15 seconds. But what we discovered together is so much larger than that single moment in vacuum. Space is not simply a place where you cannot breathe. It is an environment that methodically dismantles every biological system that defines you as human. Bones dissolve, muscles vanish, the brain shifts inside your skull, vision degrades, DNA rewrites itself. None of it escapes unchanged. And yet the astronauts who know all of this, who have felt it in their own bodies and carry the evidence in their altered genes, they keep going back. That tells you something profound about what it truly means to be human. We were not built for space. We never were. And yet we go anyway. The truth is stranger than anything you could make up. And space is the ultimate proof of just how extraordinary and how fragile we truly are. Comment star stuff if you made it to the end. I will know you are one of the curious ones, the ones who look up instead of down. Subscribe to keep looking.